Today I'm going to talk a little bit about the design of a truss. Now I'm not going to get completely in depth about it. I'm going to go over some standards, how a truss works and why it works. So what we're standing in right here is a storage truss, but the concept of a truss is different than a rafter. A truss is a manufactured piece that distributes all weights all the way to the outside walls. That's where all the weight is distributed. I don't care if there's snow on the roof, loading inside the truss, just the product itself with OSB on the ceiling, sheetrock maybe underneath. All of that, the truss is designed to take all of that weight and move it to the outside walls. That's where it is supported through the foundation. So, how is that done? When a truss is manufactured, built, designed, plates are a big key. Now, if you looked at a plate, you'd say, how in the heck does that hold? The plate, if you can look real close, the plate has very sharp indentations, about, we'll say it's about 3/8 of an inch or so. So these little points get pressed, very high pressures. When the truss is in its manufacturing stage, a plate is placed below it, a plate is placed above it, and then high pressure is placed on it that sets the plate. That is very difficult to remove. If you've ever tried to remove one before, what a pain in the butt. But for a reason. It holds very well. And they're very flat. So if you had a gable end, for instance, and you are putting sheeting on it, it's not going to get in the way. It works out real well. But a design of a truss is really a triangle, right? So a triangle is a very strong shape in construction. Now in a truss, when you place loads on a roof, what's happening is you're taking the top cord and compressing it so it wants to push out at the bottom. But what stops that from happening? The bottom cord of a truss is in tension. In other words, it's trying to be pulled apart. The top cords are in compression. They're trying to be pushed together. So they kind of work to help each other, right? So the tops want to push out, but they're fastened at the bottom outsides. So the bottom cord is not allowing it to push out. That's why it's in tension. It's trying to be stretched. So that's kind of the concept of how a truss distributes that weight to the outside walls. In this particular case, we are in a storage truss, so it's a little different design than the standard webs that are inside a truss. But you can see the gist of them. A lot of times they're called W webs, different styles, but the web, that just helps support and hold the shape of the overall truss. Okay? And part of the structural integrity of a truss is lateral bracing. In this particular case, let's say we're in mid-stride here, but the floor itself is part of that lateral bracing. When you're tying all the trusses together, you're tying them at 2 foot on center in this particular case. When that happens, a truss fails if the bottom cord is not in line with the top cord, because the truss gets very weak. Lateral bracing solves that problem. By putting this floor down, they are 2 foot on center, directly underneath the top cord, so they are stacked on top of each other. If they get off center, it's easy for a truss to fail. So that is some of the truss components and the way they work together, so it is structurally sound. And as you can see in this particular case, you can see out to the outside walls that this is a 2x6 building. When trusses are designed, they're even designed all the way down to how much shoulder or what is the end of the truss sitting on. So is it a 2x4 wall, 2x6 wall, and how big is the truss? How much weight is it designed to take? A lot goes into it. But for today, I just wanted to let you know just the basics on how a truss works and the components of it. Have a nice day.